Hi, Tyler here, and welcome to part 1 of our How-To series covering our bioengineering RALF Advanced Bioreactor. This series is designed to get you acquainted with the machine, what the machine does, how each component works, how to design and run a fermentation, pitfalls to avoid, machine maintenance, and much more. These concepts are all covered in greater detail in the operating manual, so throughout the video I've marked down section and page numbers that you can refer to for more information. This first video will get you acquainted with the machine itself. We'll take a look at the parts of the system, breaking down what each subsystem does and how they all fit together. We'll see how the machine interfaces with the operating software and go over some basic controls so you can get started turning things off and on and see how the machine looks when it's in operation. Let's get started. The bioreactor can be roughly divided into 5 main subsystems: aeration, temperature control, addition and transfer, the fermentation vessel, and the control unit. Let's start with aeration. We've connected our regulator to a benchtop air valve for air supply, though this assembly can be reconfigured for air canisters as required. The regulator prevents the system from taking the full pressure of the building's air supply, which would cause damage to the machine. There are 2 gauges on the regulator, one for the inlet and one for the outlet. The outlet air flows from the regulator through a sterilization filter, then enters the side of the control tower and is channeled to the gas module on the top right of the machine. The gas module steps the pressure down further to provide gentle aeration in the culture media. The bottom knob on the module is the pressure adjustment valve, which is another step-down regulator. Since our air supply is already controlled by the regulator attached to the benchtop air supply, this valve can generally be left in a fully open position. Above the pressure adjustment valve is the pressure gauge, showing in bars how much pressure the gas module is under. This dial should never read above 2 bars, or there is a risk of damage to the machine. The final components on the gas module are the flow meter and the flow set valve. The bearing in the flow meter gives you an approximate reading of the gas flow in liters per hour. Important to note here is that the machine must be on for airflow into the fermentation vessel. Otherwise, pressure will build in the air connections, which may cause damage to the machine. With all these parameters appropriately set, you should see bubbling from the air distributor in the vessel. The agitator in the vessel keeps the culture medium moving, providing further aeration. This is controlled by the rotary motor, the most prominent feature on the top of the vessel lid. During operation, automatic adjustment of culture aeration is measured with the O2 probe and adjusted by changing the agitator speed. Air is exhausted from the vessel through the reflux cooler, which hangs from the front of the control tower. The exhaust filter at the top of the reflux cooler must always be kept open, or pressure may build inside the fermentation vessel. Temperature control. The temperature of the fermentation is controlled by water circulating separately from the culture media through a series of pipes running through the vessel. Water is supplied to the fermenter from the chiller, which connects to the back of the control unit. This water flows from the green port on the tower to the baffling within the vessel and returns via the orange port. During operation, the temperature probe in the vessel controls the flow of water through these pipes. Above the fermentation vessel, the reflux cooler is equipped with a condensing coil to reduce media volume loss due to evaporation. Flow of water to the reflux cooler is controlled by a valve at the rear of the machine. Addition and transfer. The addition and transfer system consists of 3 laboratory bottles connected to peristaltic pumps, which feed into ports at the top of the fermentation vessel. The bottles are suspended from a cap that hangs on the frame surrounding the fermentation vessel and has 2 ports: an intake port fitted with a sterile filter, and an outlet port which connects the bottle to the pump and fermentation vessel. The pumps work by squeezing rollers along a section of tubing, similar to the peristaltic action of the digestive tract, hence the name. These pumps are controlled by the operating software and are labeled according to their default designation in the operating software. On our machine, 2 pumps feed in acid and base to regulate the pH of the culture media, and the third feeds in anti-foaming agent should it be required. These can be configured to run automatically in the operating software using measurements obtained by the pH probe and the anti-foam probe. But don't let these designations limit you. Clever use of the addition pumps can allow for flexible fermentations, and they are the easiest way to add inoculum or media that cannot be autoclaved. We'll talk more about this in a later video. The fermentation vessel. The fermentation vessel is the most important component of the bioreactor for an obvious reason. This is where the actual fermentation takes place. The vessel itself is a single-walled 1.5-liter vessel with a working volume of 1 liter. The vessel also holds instrumentation with connections on the vessel lid. We'll go over all of these connections in a later video. The control unit. The control unit, or control tower, houses the electronics and mechanical components that allow the machine to operate. On the rear of the tower are connections for water, gas flow, and the computer or Profibus interface. And last but certainly not least, the main power switch is located on the rear of the machine as well. To start the machine in operation, first flip the power switch to on. Log on to the computer and start the Profibus application. This connects the computer to the machine and begins communicating with the various instruments. This runs in the background while the machine is in operation. Launching the client program opens the graphical user interface. From here, each system can be controlled by clicking in the function block, selecting Controlled, and adjusting the input field to the desired value. And that's it. We'll go over the operating software and the kinds of control you have over your fermentation in a later video, but this should get you familiar with the machine and how it works. In the next video, we'll go over how to disconnect the vessel assembly for cleaning, and the proper procedures for cleaning and sterilization after you've finished a fermentation. See you next time.